Hello, it's me, Randall, and I created the Periscope. So, what I did for our project is I pretty much went over the theory and the conclusion. Now, as far as the theory goes, the Periscope works all on the law of reflection. Now, you might be wondering, what is the law of reflection? Pretty much, it goes based on when you have a ray of light, it comes at you. Well, since we're using mirrors, as it comes towards this mirror, it has a normal line in between it, and then it shines right back at you. Now on my phone, I do have a diagram that you can check out. I don't know if you can see this, but let's try. There you go. Okay, so pretty much you know that as it goes, it reflects perfectly. Now, something that a lot of people don't know is that light is pretty predictable in the manner that as it falls and as it goes. So, the next law that we have to look into as based off of the law of reflection is pretty much the Fermat's principle, which pretty much goes that as one light goes from here, it will go directly in a straight line that's the shortest straight line towards another path. So from there, it reflects off the mirror once again. And then, as I showed you in the diagram, the light approaches the mirror, and that's, like I said, known as the incident ray. And then the line in between, which was the dotted line, it was the normal line. And then, so we've talked about the law of reflection. Now it's time to talk about Fermat's principle. Now, what is it? It's pretty much stating that light uses the pathway that is the shortest amount of time. So if as we look at the lights in here, there's multiple pathways that it could take. But in order to get to my eye, instead of going all the way, bouncing over there and coming back towards me, it comes directly towards me. And so that's how the light rays react. Hello. Now it's time to talk about how I built the Periscope. Follow me. Ouch. Cardboard box like this will work, you know? All you have to do is pretty much get a pair of knives, a utility knife, that's what we use, and then, you cut out 2 long strips and then 2 shorter strips, in which that way you can fold them and glue them together with some hot glue, which once again, I apologize, I do not have with me. And then you also have 2 smaller mirrors, which are about 2 centimeters long and short, and then you put them in there. So, let me show you as though I'm gonna pretend that I'm making it. I apologize for all the ums. So, hot glue gun, stick, wait at least 10 seconds, then you get the other side, wait another 10 seconds, then you place that part upon the ground, and then you take your last strip, this piece, glue, pick it up. Let me draw it for you. Follow me. I'm actually going to be. This is Mr. I. He's not important right now.
Oh shoot! And it comes back twice.
You guys. This is basically what the Periscope will look like. So you have your 2 mirrors right here, all at 45-degree angles. Once again, we're using Fermat's principle and the law of reflection at a 45-degree angle. That is the perfect sign. Now, I would like to also include that there are a few equations, thanks Mr. I, that you have to call upon, which is the law of internal reflection. Now, I didn't entirely understand that whole entire equation myself, but it was like theta is equal to the sine of pi over 3 times 4 or something. I don't know. Scientists these days are crazy, And then once again, I have the reflection and the incidence ray, just to let you know, remind you of what the law of reflection is. Alright, stop. See that the Periscope has worked out pretty correctly for us. We was able to create it at a perfect 45-degree angle, and we're able to see things that were around us that weren't perfectly